Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through binomial expansions. So binomial means two terms. So what we're going to look at situations where we have two sets of brackets, each with two terms. So the first bracket has two terms x and 3, the second has two terms x and 2. So what we are going to do is multiply the first bracket by the second bracket, and we want to end up with something that has no brackets. So starting with brackets, ending up without brackets is expanding. Going the other way is called factorizing, that we'll look at in subsequent lessons. So the idea here is we want to multiply everything in the first bracket by everything in the second bracket. So we want to multiply x by x plus 2, and we want to multiply 3 by x plus 2. So in order to make sure that we don't forget any terms, we're going to follow the process called FOIL. So FOIL is an acronym that stands for firsts, outsides, insides, and lasts. We multiply the things that come first in each bracket, the things on the outside of each bracket, inside of each bracket, and the things that occur last in each bracket. So to illustrate this, let's actually go and figure out how did I get this answer when I started with this. So if we're going to expand these brackets, we have the things that occur first in each bracket. That's what that means here. So we have x times x because we're multiplying, and that of course just gives us x squared. So then O outsides, so that was F. O is the thing that occurs outside in each bracket. It's x times 2, positive 2x. Then I insides, 3 times x, and then finally L, lasts, means the things that occur last in each bracket. So 3 times 2 is positive 6. Of course, these two terms here are like terms, so we just add them together. And that's how we got our answer of x squared plus 5x plus 6. Let's say we have x minus 1 times x minus 4. So firsts, outsides, x times minus 4. Insides, minus 1 times x, and then lasts, minus 1 times minus 4. Once again, we collect like terms. We get x squared minus 5x plus 4. So this kind of expansion, where you have the same thing in each brackets, but one has a plus and one has a minus, we'll see that that simplifies quite nicely. So firsts, so then outsides is x times positive 3, insides is x times negative 3, and then lasts is minus 3 times positive 3. So when collecting like terms, 3x minus 3x is 0. So we can actually get rid of these middle terms because they equal 0, and we're just left with x squared minus 9. So sometimes you will have to expand something like x minus 4 squared. So remember, when we square something, we're just multiplying it by itself. So you can use FOIL with this again. So first is x times x. Outsides, x times minus 4, insides is minus 4 times x, and last, minus 4 times minus 4, and simplifying that we get x squared minus 8x plus 16. Alright, now we're just going to go through some quicker ways to perform these expansions. Please pause and copy down if you need. So if I were to use FOIL on this here, x plus a, x plus b, notice I get an x squared term. The coefficient of x is these two numbers added together, and the constant term is those two numbers multiplied together. So I can use that to perform binomial expansions quickly. So if I want to quickly expand x plus 3 times x plus 4, it's x squared. Coefficient of x is 3 plus 4. Constant term is 3 times 4. X minus 5 times x minus 9 is x squared. Coefficient of x is minus 5 plus minus 9, and the constant term is minus 5 times minus 9, which is positive 45. So x minus 8 times x minus 5, x squared. Coefficient of x is minus 8 plus 5, and the constant term is minus 8 times 5. Of course, minus 40. So note, this only works if the thing is monic. That means that the coefficient of x is 1 in each bracket. So another quick way we can perform a binomial expansion is with the difference of two squares. So I showed you an example like this on the previous slide. Remember where I rubbed out the middle term? That's when you have the same thing in both brackets, both x's, both have an a, but one has a plus, one has a minus. The quick way to do it, square the first, square the second, stick a minus between them. So if I want to expand x minus 3 times x plus 3, square the first, square the second, 3 squared is 9, stick a minus between them. How easy is that? So let's say I have 2x plus 5 times 2x minus 5. This is difference of two squares. We've got the same two terms in each bracket, but one has a plus, one has a minus. Doesn't matter whether the plus is before or after the minus. So what we do is we square the first term. So 2x all squared gives 4x squared. 2x times 2x is 4x squared. Square the second. 5 squared is 25. Stick a minus between them. How easy is that? So note that we would have got the same answer here if we used FOIL on this. It's just that this is a quicker way. Similarly, we would have got this answer if we used FOIL on these two brackets. We just arrived at the answer quicker. So now we're going to look at how to do perfect squares quicker. So if I use FOIL on the expression x plus a all squared, I'd get x squared plus 2ax plus a squared. So the quick way to do this, what we've done is we've squared the first, we've squared the second, but there's a middle term, and it's 2 times the product of the two things in the brackets. So to do x plus 2 squared, square the first and we square the second. Now most people make the mistake of stopping there and saying the answer is x squared plus 4. It's not, there is a middle term, and the middle term is 2 times 2 times x. So that is positive 4x. So that goes in the middle. So let's say we have x minus 7 all squared. Square the first, square the second. Now, minus 7 squared is still a positive. So we get positive 49 at the end. So what goes in the middle? 2 times negative 7 times x. So this time it will be a negative in the middle. It'll be negative 14x. So like the difference of two squares rule, this still works even if it's non-monic. It's non-monic because the coefficient of x is 2. So what we do is we square the first, 2x all squared gives us 4x squared. We square the second, and what goes in the middle is 2 times 3, 6 times 2x. So that is 12x, and we're done. So unfortunately, there isn't always a quick way. If the thing is non-monic and it's not a perfect square or difference of two squares, you will have to use FOIL. So if we're expanding something like this, there is no quick way to do it. We just have to use FOIL. So if we were going to use FOIL, first 2x times 5x, outsides 2x times minus 4, inside's 7 times 5x, and then outside 7 times minus 4, and once again we collect like terms, minus 8x plus 35x gives us 27x, like that. And we are done. Alright, thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.